Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is a continuation on a lecture for intermediate algebra concerning quadratic inequalities. We just finished part A, which was a review of interval notation, so you should be all caught up on that idea and how to state an inequality in interval notation, and also how to graph an inequality. And in this part, which is part B, we're going to go ahead and solve quadratic inequalities graphically. Now, the best way to illustrate solving a quadratic inequality by graphing is just to start with a basic parabola, something that we don't know the equation for, but instead we're just going to kind of ask some questions about some given graph. So let's suppose we're given this parabola here, and notice I marked up the tick marks here on the axes. So let's suppose we're asked a question, and again, we could pretend this represents an equation like y equals x squared minus 5x plus 4 or something like that. I'm not saying that's exactly what it equals. I'm saying let's pretend for a moment that is what this equals. We could ask a question like, for what value is y less than 6? When is y less than 6? In other words, when is x squared minus 5x plus 4 less than 6? It's really just asking, when is this parabola below a height of 6? Whenever I look at a y value, I always think that means a height. So, for example, in this equation, it's asking me when is the height equal to x squared minus 5x plus 4. In this inequality, it's asking me when is the height less than the height of 6. So let's take a look at this right here. So we want to just know, when is this parabola below a height of 6? So let me just draw a line at a height of 6 here so you can kind of visualize what a height of 6 is. This right here is just y equals 6, a line, an imaginary line. We're just creating at a height of 6. And I just want to know, for what x values is this parabola below that? Let's see. If I draw a line straight down here and draw a line straight down here, just to kind of get an idea, it looks to me that whenever x is between whatever this x value is, let's say that's negative 1.8, to whatever this x value is, and let's say that's a nice clean x equals 4. So when x is between negative 1.8 and positive 4, the parabola actually lies below a height of 6. So I'm just shading it in here. I'm just saying it's in this region, this area that I'm shading, that's when I'm below a height of 6. If you really want to think about it, you could think about a light being shown up above, and essentially you're just asking, if you're asking when am I below this line, you want to shade everything below that line. So I'm going to create a shadow down here of all the stuff that's below the line y equals 6. It's all that stuff that I've shaded. All those x values lead to the parabola, the area on the parabola that's below a height of 6. So the answer to this question, at least according to this, and by the way, again, this is not for actually for this equation, so please do not try to do this algebraically yet. But if it were, then we could say, oh, okay, it looks to me as though it's all the x values that are between 4 and negative 1.8. Notice that I'm not including negative 1.8 and I'm not including 4 because I want to know when my y values are strictly less than 6. Not equal to, but when they're strictly less than. So I have to use the same equality, or inequality, I'm sorry. And writing this in interval notation, which we just brushed up on, we know the lowest it can go is 1.8, negative, and the highest it can go is positive 4, and we're not including either endpoint. So that's how you do this using a graph. Now let's actually go ahead and try this with an equation and use the graph of that equation to help us solve an inequality. So in this problem, we're going to go ahead and use the graph of y equals 3x squared plus 6x plus 1 to estimate when 3x squared plus 6x plus 1 is greater than or equal to 4. And then after we're done with that, we'll go ahead and find out when 3x squared plus 6x plus 1 is less than 2. So we'll do a couple of these problems here. So I quickly create an x and a y axis, and then I'm going to go ahead and graph this quadratic equation, the top one here, and I'll use the method that we've been using in the past. So recall I mentioned a long time ago all parabolas hit the y-axis, so let's find the y-intercept. That occurs at 0, 1. So I just plot that point in there. Then I ask myself, when is y equal to that output of 1 again? So let's go ahead and find that out. We'll just let y equal 1 in our quadratic equation here. We get the 1 is equal to 3x squared plus 6x plus 1. We'll subtract 1 from both sides and get 0 is equal to 3x squared plus 6x. The right-hand side can be factored. Pull out a 3x out of both of those. So this implies that 0 is equal to 3x times x plus 2. Actually, all these imply each other. And we have two objects multiplying together to become 0 means either the first object is 0, which implies that x is equal to 0, or the second object is 0, which implies that x is equal to a negative 2. Okay, so what does this mean? It means that we have, or that our parabola is at a height of 1 when x is 0 or x equals a negative 2. Now, just for sake of drawing here, I'm going to go ahead and pretend each one of these vertical grid lines is a half. So that'll be a negative 1/2, a negative 1, a negative 1.5, and this will be a negative 2. I'm just doing that because I know that this is going to be easier for me to see. And I'll label this point as well. And now all I need to do is find the vertex. The vertex occurs halfway between those 2 points. So I know that the vertex is at x equals negative 1, and then y equals whatever happens when I plug negative 1 in for x. So let's go ahead and do that. When I plug in a negative 1 for x, I get the following. Let's see, negative 1 squared is 1 times 3 is 3, minus 6 is a negative 3, plus 1 is a negative 2. So plug in negative 2 there. So let's see, when we're back here at x equals to negative 1, the y value is a negative 2. Something like this. There we are. And I'll even write that point in. Now at this point I would normally say let's go ahead and just connect these dots. But because I want to be a little more exact here, I'm going to go ahead and plot a few more points. Well, maybe I won't. Maybe just to kind of keep it a little more realistic that you might be graphing this by hand, I'll pretend as though we're doing this. I'll pretend as though we're trying to be as exact as possible, but still being sort of free form with it. Now the question is, first part of this question is, when is this parabola above the height of 4? Well, let me draw in the height of 4. Here's the height of 1, 2, 3, and 4 is right here. And I'll draw that in as a dashed line. Maybe I'll use a gray dashed line. I don't know if that's visible. Oh yeah, that's perfectly visible to me. So here we go. So that's the height of 4. And I just want to know, when is this graph above that height? Above or equal to that height? So let me shade in when the graph is above or equal to that height. Here on up, all that part of the parabola is definitely higher than a height of 4. Same thing over here. Something like that. I kind of bled that over a little bit, but that was for a reason. In fact, just to be more exact, I even cleaned it up even more just by pressing pause and doing that. Okay, so it looks to me as though we are at or above this height of 4 where I have shaded in blue. And it's really asking what x values will give me those the parabola above that y equals 4 line. Because if you look at this inequality right here, there are no y's involved. It's actually asking what x will make this true. So if you use that spotlight idea, that a light's shining down from above, it will shine straight down onto the x-axis here, and anything that you have shaded will shade onto the x-axis. So I'll shade all this stuff. It'll actually shade this way forever because, because the parabola widens out, keeps widening out. So all this stuff will be shaded. Okay. And so the answer to this first one is going to be anything starting, remember you start low and go high with inequalities. So anything starting at negative infinity and climbing all the way up to, oh, that looks like x equals, looks like actually the way I drew it, x equals a negative 2.5 maybe. We'll discuss why this is incorrect in a moment. And then we need to union that interval with another interval. But before I do that, I'm going to mention, because we want our outputs to be 4 or more, in other words, we could be at a height of 4 exactly, then I'm going to include this input of a negative 2.5. Okay? And now I'm going to skip all this region that doesn't get the shadow, and then on the other side of the region, I'll go ahead and continue on. It looks like it picks back up at x equals 1/2 here. So we'll start at x equals 0.5 or 1/2, and it continues on to infinity. You can never touch infinity, so that's okay. But this x value of 0.5 that's right here, we do want to be at that because remember, our output can actually be 4. So let's go ahead and include that input of 0.5. Now there is a little slight issue with this, in that because I graphed by hand and I wasn't plotting a ton of points, only plotted 3, that my graph is actually incorrect. So these numbers are actually incorrect as well. If I wanted to do this properly, I would need to really spend some time graphing it by hand. One way that you can do this is to use a graphing calculator to kind of do most of the work for you. You could access the graphing menu, remember, by these top buttons up here. Hit the y equals to enter into equations, or enter your equations in, I should say. And what you want to enter in is actually 3x squared plus 6x plus 1. That's the equation of the parabola. So 3x squared plus 6x plus 1. And if I just hit graph right now, I might not get the best graph. Actually, I get a pretty decent graph. But now if I want to know when is this graph above the height of 4, I'd have to kind of zoom in here or something and try to figure it out. There's actually an easy way to do this. You could graph a vertical or a horizontal line on your TI just by saying, well, I also want to look at the line y equals 4. Because that's really what that horizontal line is the line y equals 4. So if you hit graph now you see, aha, I am above that line y equals 4 in this region right here on the left post and the other region on the right post. You can actually find what these regions are by finding when the curve intersects the line. This is a very advanced calculator move, but it's pretty cool to see. If you want to know when two lines or two curves intersect on your TI graphing calculator, you can go to your calculate menu, which is accessed via the trace button. So second, and then hit the trace button, and you have all these options on here. You can find the value, you can find a 0 of your graph, you can find the minimum of your parabola, let's just say, or the maximum if there is a maximum. But the one we're concerned with now is the intersection of these two. So go ahead and select that one. And it'll ask you, where's your first curve? And you see that little cursor right there. Let me just click to the left. You'll see I can move it around. All it's asking right now is this the first curve that you're concerned with? I might have 20 lines on the screen. That's why they're asking that. So just hit enter to say, yeah, that's my first curve. They'll say, is this your second curve? Yep, that's my second curve. And then they'll say guess. The reason why it says guess is because look how many times our parabola hits this line, this horizontal line, twice. So if I don't provide a guess, as to the intersection, it doesn't know which one I'm going to want, and it might return the one I don't want. So let me just get close to that. I don't have to be right on it, but close enough is fine. Hit enter, and it'll tell you it intersects at x equals a negative 2.414, and then at a height of 4. Actually, our guess is pretty good. We said negative 2.5. That's pretty good. I was worried it was going to be bad. Huh. So in reality, it's negative 2.4 is the x value where they intersect. Now I can do that again to find out where they intersect on the right-hand side. Remember, we said it intersects at 0.5. Let's see what happens here. Second, calculate. And I'll select the intersect feature. Again, it's just saying, is this your first curve? Yep, it is. Is that your second curve? Yes, it is. And now get really close to the point. It wants you to take a guess, so I'll take a guess that it's right there. Hit enter. And 0.414 blah 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 is where the x value where they intersect. So again, our guess is not so bad. That's actually better than I thought it would be, to be honest with you. Now remember that the second part of that, part B, was asking us when is 3x squared plus 6x plus 1 less than 2. So all I did was copy that graph there. I know there's still some heavy shadowing on the curve, but we're just going to ignore that for now. I want to know when is this graph less than a height of 2. So let me draw that height in there. So there's our vertical line. I'm sorry, our horizontal line at y equals 2. And I just want to know when are we below that. So I'm going to go ahead and shade that in red here so that we can really see it. That parabola seems to be below a height of 2 where I'm shading red. And if you again think of a light shining down that creates a shadow on the axis, it'll probably make a shadow like this. All the way up to probably about there. Okay. So let's try to take a guess as to what these values might be. Just eyeballing it, I'm probably going to say that this is x equals, I don't know. Let's see if that's negative. It's probably about a negative 2.1. And here, this is probably x equals, looks about equals a 0.5 or something like that. Actually, that's probably not true because I had to shift. I realized that when I pasted this graph in, that I pasted it in without properly pasting it on the axis. So I'll go ahead and say that again, this time trying to be proper with it. So it seems to me, now that I'm looking at it from a more a nice grid-like point of view, it seems to me that that x value, I guess that still is about a negative 2.2 or something like that. And then the other x value looks to me to be slightly less than a half, maybe about a 0.3 or 0.4 or something like that. So that's just eyeballing it. But now remember, we're shading in that region. So the lowest low of the x values in that shaded region will be a negative 2.2. Let me just draw that in green here. So from a negative 2.2 all the way up to a 0.3. And because this inequality is strict, we're actually not going to ever want to be at a height of 2. So we don't want to actually touch these x values here. We just want to get really close to them. So I will put these parentheses on there, meaning we can get up to a negative 2.2 but not actually touch it. Same thing, we can get up to 0.3, but we really cannot touch 0.3. So let's see actually how this looks on the graphing calculator. Now recall from last time that we had the parabola and then we graphed the line y equals 4. Here we're going to actually graph the parabola and the line y equals 2. I hit graph. There's the parabola, there's the line, there it is, the line y equals 2. Let's find out when the parabola hits that line by just going second trace and selecting intersect, which is number 5. First curve, yep. Second curve, yep. And I might as well guess the right-hand point first. So I'm right there. 0.15. So our guess was pretty far off. We said it was a 0.1 or 0.3. So that's what you get for eyeballing, right? And then we'll do the leftmost point here. Okay, yeah, that's the first curve. That's the second curve. And let's guess. Let's get really close to the point that we want. And this tells me it's going to occur at negative 2.15. That's actually a pretty good guess. We've rounded to the nearest tenth. How's that? So that's not too bad. But you can already see the weaknesses of using graphing to solve a quadratic inequality. It's that you can never really graph it perfectly enough to give you a good idea, especially with most quadratic inequalities. Most of them very difficult for you to guess offhand where the parabola is above a certain height. It's just very hard to eyeball that. So in the next lecture, we'll discuss how to do this using mathematics, algebra.